In this video I'm going to show the E field. E field means electrical field, and as you can see by this flash I've drawn, I mean electrical. Okay, electrical field means that if you have a transmitter like the CB radio here and have an antenna, the antenna is generating an electrical field. I will show you that. This is an energy saver bulb. The energy saver bulb will light up, although as you can see there is no physical connection between the antenna and the light bulb. So what happens is that the electrical field goes into this gas tube and lets it light up. So I'm now going to push the torque on my CB radio, and as you can see the LED for transmit goes on, and as the LED for transmit goes on, the energy saver bulb goes as well. So every time I push transmit, you can see that this energy saver bulb is lit up. Because, as I said, the antenna is generating a magnetic field that goes into this gas-filled tube and enables it to light up. But there's a problem with this E field. The problem with the electrical field is that the general transmission power on every frequency is limited to 4 nanowatts. In the next clip you will see an H field. So now let's talk about the H field. The magnetic field, as you can see I've drawn a magnet here, of broadcasting. I have an experiment here which contains a transmitter and a receiver. As you can see, the receiver has nowhere a hidden battery. It's just a coil, a capacitor, a LED. What happens if I bring the receiver close to the transmitter? Can you see? The LED lights up, although there is no physical connection between the receiver and the transmitter. So energy is wirelessly broadcasted into this circuit that lights up the LED. In this basic, we are going to build our transmitter. So what is this and this? These are coils. This is nothing else than this coil here. Here you can see a better demonstration how it would look like. Of course it has a different value in terms of microhenries and some other stuff, but basically it's the same. There is a special material which is called ferrite, and there is a coil wound around the ferrite. The coil wound around the ferrite will generate a magnetic field if it's supplied with a high frequency or alternating current at a high frequency. It will also generate a magnetic field if you would apply it to your battery, but it doesn't work as you want it. Just keep it as it is. Anyway, so if we are applying a high frequency on that coil, it will generate a magnetic field which is then broadcasted, if you want to call it like that, by this ferrite staff. So the ferrite staff is generating a magnetic field around the coil. If you would hold the energy saver bulb that you saw in the previous video close to the coil, it wouldn't light up. But if you add on the other side another coil, then the coil will pick up the magnetic field with this ferrite staff. So now there is a magnetic field going on this ferrite staff. The coil will convert the magnetic field back into electricity, and what happens is what you can see in this experiment. You can broadcast energy wirelessly into a LED. But we are not here to broadcast energy wirelessly into a LED. We are here to make our own radio program. So here is a cheap AM/FM radio. I'm sorry, it's somehow stuck there. Anyway, here is a cheap AM/FM radio. As you can see, it has FM and also it has AM. And we want to make our AM transmitter so this radio can pick it up. So here I can tell you, in these radios there is one of these ferrite staffs. Each radio, each portable radio, has one of these ferrite staffs inside. Not this one. It could be a little bit smaller but therefore thicker. Also the coil could look different, but basically all are using this ferrite antenna. So they have a coil and a ferrite staff. What the transmitter is going to do, it uses this coil, this type of coil. It looks like a resistor, but it's a coil. This is basically the same thing than this thing, just in small. What it does is this coil is going to generate a magnetic field with our broadcast signal. The radio's antenna is going to pick up the magnetic field. The coil is converting it back into electricity, and our radio can receive our own broadcast. There's one special thing about here, which is the allowed field strength. As you could see on the E field, we have 4 nanowatts allowed, which is definitely not much. But here we have minus 15 dB microamps at a distance of 10 meters. Blah 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 blah, that's not interesting. Blah 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 blah. This is interesting. 10 meters. I've done really some huge amount of research before I made this video, and I can tell you, if you stay in the range of 10 to 12 feet, there's nothing wrong with your transmitter. Of course, not measured with a cheap radio like this, measured with an expensive radio which has high sensitivity. If you stay in the range of 10 to 12 feet, that means your signal starts to get much static at that range. It disappears in the static, everything is fine. And our transmitter is going to be weaker than that. So in theory, this transmitter should be allowed everywhere in Europe without applying a license for it. So these are the components that are required for building the transmitter circuit. Here we have a transistor, could be a BC547 or 2N3904. A red LED, it's important that the LED is red, not a green LED or yellow, it must be a red LED. A capacitor, 100 microfarads, 16 volts. A 1 nanofarad capacitor, written on it 102. Another 1 nanofarad capacitor, written on it 102 as well. Some 100 nanofarad capacitors or 0.1 microfarad that have written on them 104. And resistors. These two are 1K resistors with the color code brown, black, red. Then we have a 4.7K resistor with the color code yellow, purple, yellow. Then we have a 4.7K resistor with the color code yellow, purple, red. And a 15K resistor with the color code brown, green, orange. And finally, of course, our 100 microhenry inductor. These are all components that are required for building this simple transmitter. Now let's talk about the 100 microhenry coil. I want you to use this 100 microhenry coil, and there are many variations. There's also a version in green. This coil also exists in a smaller shape and also in many different other shapes. It can be a coil like this, or it can be a coil like this, a coil like this, or like that, or it can even be a variable coil. Everything will work fine as long as the value is around 100 microhenries. If you are skilled, you can also take a farad staff and wind your own 100 microhenry coil with wire around the farad staff. Keep in mind that it should be around 100 microhenry, and so you want to measure your inductance. These coils that you will find in an old power supply probably won't work. Meanwhile, this coil here has as core material some ferrite material, ferrite. This one has iron powder core. An iron powder core won't work on that high frequency that well as this coil will. So as you can see, there are a huge amount of coil variants that you can use for your transmitter project. Just keep in mind it should be 100 microhenry, which has, by the way, the color code is, as you saw, brown, black, brown, gold. So now let's have a look at the components. You can use a 4 AAA or AA battery holder or a 9V clip. Depending on if you want to use 4 AA or AAA batteries or 9V battery, you buy a clip for 9V battery or a battery holder for the AA or AAA batteries. You want to buy 1 feet long wire, flexible wire for connecting your audio source, and of course a solderless breadboard. I'm using this one, but you can also use another one. It's just important that in the middle of the solderless breadboard there is this place where you could normally stick in integrated circuits. For connecting your MP3 player to the solderless breadboard, you need wires. You can either buy a pair of these, but I recommend these. So now let's use the wire. This is the 1 feet long wire. Cut it in the middle. The first thing I want to do is cut the wire in the middle. So you cut it in the middle so you get 2 equally long wires. So here we go. Now you get 2 equally long wires. Now you go ahead and uninsulate it on one side 1 inch long. So remove the insulation from the wire. On one side 1 inch and on the other side 1/5 of an inch. So it should look like this. And now we are doing this twice. Okay, so now we have this wire and now we are going to get the wires together. We are doing this with the hand, but be careful, they can sting you. Do this on your own risk. You turn it, which is very hard because I'm having barely any space on the camera. You turn it, as you can see, you turn it. So this is how it should look like. So do this also on the 5mm side. Or 1/5 inch side. Do that on both wires. So this is how the wire looks before, and this is how the wire should look like. Do this with both wires on both sides. Now you take your audio connector, connect it here and there. I'll do that off camera. So I'll do that in camera. Wind it a few times around the outer side and then do it like this. So it should be wrapped around this thing so it holds. So this is how you do it. So this is how you do it. And do that also with this wire. Wrap it around. So, well, I try to make it on camera, so this is how it's supposed to look like. So this is how it's supposed to look like. Okay, now this is your audio cable prepared for connecting it to your transmitter. So this is how the wire gets connected to the transmitter. So wird der Draht an den Ständer angeschlossen. So this wire here, dieser Draht hier, this wire goes to here, goes to the 104 cap. Dieser Draht geht zum 104 Kondensator. Das hat natürlich jetzt einen Wackelkontakt bei meinem alten Steckboard. And the outer wire goes to ground. So there's still one ground left. Also der äußere Draht hier, der geht hier auf Masse. Neben den schwarzen Draht. Hier, unter der LED. Below that LED. You can see where it goes. So this is how the audio connector connects to your transmitter. So verbindet man den Audioanschluss mit dem Sender. So now let's have a test of the AM transmitter. On my audio source I haven't adjusted the maximum volume, I have adjusted nearly the maximum volume and it's already playing a test recording. My transmitter is on and I've placed my radio close to my transmitter. I've aligned it to the lowest frequency possible. Now the radio is on, let's search the transmitter.
Video zur Beschreibung der Grundfunktionen eines einfachen Walkie-Talkies mit Pendelempfänger. Testsendung 1, 2, Testsendung 1, 2. Selber gebaut.